Hello there, I'm Zach, and I'm a developer at Microsoft working on Node.js tools for Visual Studio. In this video, I will give you a whirlwind tour of the NTVS debugger features. To get started debugging, let's first create a new project. Here I create a blank Node.js web application. Now that we have a project, let's go ahead and start debugging. This is easily done from the Debug Start Debugging menu. Note that when you start debugging, NTVS both launches your Node.js application as well as launches a browser pointing to it. With this, we're ready to do some actual debugging. The first thing I'll show you is setting a breakpoint. This can be accomplished by clicking in the margin on the left-hand side of the editor, as well as right-clicking on a line of code, choosing Breakpoint, Insert Breakpoint. Now that we have breakpoints set, refreshing the browser should have the effect of hitting our breakpoints in the debugger. Now's a good time to show you how to manage breakpoints. You can disable a breakpoint by right-clicking on it and choosing Disable. Clicking on it again re-enables it. It's also possible to remove a breakpoint simply by clicking on it. All these changes are reflected in the breakpoint window. It's also possible to manage things from here. Enabling disabling is performed using the checkbox, and simply hitting delete on a selected item will remove a breakpoint. Currently, our application is broken in the debugger. This is indicated by debugging showing in the title bar. This is a great time to show stepping. Stepping is accomplished using the stepping commands. These commands are available in the debug menu as well as on the toolbar. Stepping in has the effect of moving the instruction pointer into a called function. Stepping over steps instruction by instruction without stepping into a called function. Stepping out has the effect of exiting the current function. The fundamental usefulness of a debugger is the ability to inspect the state of your running application while it's broken. First, let's look at the Modules window. This window shows all the modules that Node.js has loaded for your application. The Locals window shows the local variables for your current function. It's effectively a tree view where you can open up variables to show their constituents. The Watch window allows you to evaluate arbitrary expressions. The expressions are evaluated in the context of your application broken in the debugger. It provides a tree view much like the Locals window. The Call Stack window provides a backtrace of your call stack where you're broken in the debugger. It has an element for each of the functions in the call stack. Double-clicking on a line will open up the file containing the function for that line. It's worth noting that it's possible to open up built-in scripts that are part of Node.js proper. The NTVS debugger treats built-in scripts just like any other script, so it's possible to do things like set a breakpoint and continue. And when we refresh our debugger, we actually hit our breakpoint in built-in script. The immediate window behaves much like a Node.js REPL, only the behavior is in the context of your running application as broken in the debugger. You can do things like inspect state, modify state, and the like. NTVS supports break on exception in its debugging support. What this means is that if we run under the debugger and we hit an exception, we end up seeing UI for the exception with the exception details. By default, NTVS breaks on all Node.js exceptions. However, this is configurable from the UI that pops up on exception, as well as from the Debug Exceptions menu. In the Exceptions dialog, it's possible to set the exception behavior for each individual exception. When broken on an exception, all of the state inspection available to you when broken after stepping or on a breakpoint is also available. So you have your Locals window, Watch, Call Stack, etc. NTVS also supports advanced breakpoints. It supports a couple of types. It supports breakpoints with conditions, with hit count, and with when hit criteria. It's also possible to configure advanced breakpoints from the breakpoint window. Here I'll go ahead and make a conditional breakpoint. You can use the Breakpoint Condition dialog to set the criteria or condition for a breakpoint. You have the option of enabling or disabling the condition, where the condition is an expression that is evaluated. Let's say something like exception equals null. Right. So then you have the option of whether or not to break if the condition is true or is changed. Breakpoints may also be configured to break based on hit count. You have the option of breaking always, which is essentially disabling this feature. You may also break when the hit count is equal to some number, a multiple of number, or greater than or equal to a number. If you choose something other than disabled, you need to provide an integer, which is the hit count at which the criteria fires. It's worth noting that in the hit count dialog, you can look at the current hit count for a given breakpoint, and you can also reset it. One more advanced breakpoint feature worth mentioning is the idea of when-hit breakpoints. When-hit breakpoints allow you to print a message when your breakpoint is hit. The message is made up of text and placeholders which were replaced at the time that your breakpoint is hit. When your breakpoint is hit, you have the option of silently continuing execution, which is the normal case. When this is the case, this is what we call a trace point. There's actually a more direct way to create a trace point. You can simply right-click on a line of text and choose Breakpoint, Insert Trace Point. This takes you immediately to the When Breakpoint is Hit dialog. Okay, let's try remote debugging. In fact, let's try remote debugging to our application running on a Linux server. Behind the scenes, I've used the Azure portal to create a Linux VM. In addition, I've opened up a command prompt on that VM and ensured that Node.js is in fact installed. It's worth noting that I've exposed a couple of extra endpoints for my VM. First, I've exposed HTTP of 80 for my app's hard-coded port. In addition, I've opened up the Node Debugger port, which the default is 5858. In order to remote debug, I need to ensure that the remote debug proxy is available on the target machine. The remote debug proxy can be found under Node.js Tools, Remote Debugging Proxy, Open Containing Folder. Once again, behind the scenes, I've gone through the process of deploying both the remote debug proxy as well as my application to the Linux machine. So if we take a look on the machine, we see all of this here. Now we're ready to run our application behind the remote debug proxy. This is accomplished by running Node.js. On Linux, it's actually called Node.js. Running the debug proxy and then passing it our server. At this point, our application is running on the Linux server behind the remote debug proxy. Here, the remote debug proxy is essentially mapping a local host port to a public port so that it's accessible from the NTVS debugger. At this point, we're all ready to try to attach the remote debugger. So let's give that a try. Use debug attached to process to bring up the UI. For transport, you want to use Node Remote Debugging, and for qualifier, you want to use your remote machine and provide the port to the Node.js debug protocol. The default for that is 5858. Once you've provided this information, you can choose to refresh. This should show your process running remotely. Once you've done this, go ahead and attach. At this point, we're actually remote debugging our Linux server. So let's go ahead and point a browser at our website and see what happens. Go ahead and do that here. Check it out. We actually hit our breakpoint. So when you're remote debugging, you get all the same features as if you were locally debugging. So you have your call stack, locals, modules, etc. I hope you enjoyed this whirlwind tour. Happy debugging, and if you have any comments or questions, please refer to nodejstools.codeplex.com. Thank you.